Hi, my name is Liz Thompson, and this is a video for IME 315, Financial Decision Making for Engineers at Cal Poly San Luis Obispo. This video is on time value of money. And when we look at the 5 areas in which we're talking about the topics in this class, this topic falls under investment analysis. So the things I'm going to be talking about today are really the main concepts associated with engineering and economy, which is that you can shift cash flows from one time period to another using interest equivalents. And all cash flows that are occurring at the same period of time are additive. So those are the two main rules that we're going to be talking about, the assumptions. So let's go back and look at, if we remember the basic definitions in the engineering economy, where we have this timeline and we have the periods 0 through, in this case, N, and the up arrows are positive cash flows and the down arrows are negative cash flows. We also assume an end-of-year convention. So with this kind of background in engineering economy, we can ask questions like, would you prefer $90 now, $80 now, or $90 in 1 year? Now, if these had occurred, so this is what this looks like in the cash flow, $80 now or $90 in 1 year. Now, if these had occurred at the same period of time, it would actually be quite easy. We would just say, well, we prefer $90 over $80 because it's bigger. But in this case, because it doesn't occur in the same period of time, the question we need to ask is, if I had $80, what would I do with it? And let's just say that we would put it in the bank and we'd earn I% interest. And in this case, I'm just going to assume a 5% interest. So now I'm going to actually be shifting that $80 to 1 year in the future, and then I can directly compare it to the $90. So in 1 year, I'll have $80, plus I'll have the interest that I earned on $80 at 5%. And I just do the algebra, which means then I'd have $84 in 1 year. So now the cash flow looks like this. $80 today is the same as $84 in 1 year, and now I can compare them. And it's clear then that I would prefer to have $90 in 1 year as opposed to $84 in 1 year, which means we would prefer $90 in 1 year as opposed to $80 now. That's would be our preference then. So what we did is we shifted to a common time period, and then we could directly compare. Now let's just look at it again and say, well, what if this was a 2-year process? So instead of $90 in 1 year, we're going to say $90 in 2 years versus $80 now. So now we need to shift to 2 years into the future in order to compare these to each other at the same time period. So again, I'm going to assume I make 5% interest. The interest rate that I can make in a bank is 5%. So I say in 1 year, I'll have $80 plus the interest I earned on it of the $4, so I'll have $84. And then in another year, I'm going to take that $84 and I'm going to earn another year of interest, which is the same as taking $80 and having 2 years of interest, 1.05 squared, which means it's going to be the same as $88 in 2 years. So now again, I can compare the time periods are the same now. So it would be $90 in 2 years or $88 in 2 years. And we would still prefer $90 in 2 years. So what I've just gone through is sort of a logical justification of really the only equation that you'll need to know in engineering economy, which is the future value. So that's the value into however many n periods in the future is equal to the present value times 1 plus the interest rate to the power of the number of time periods that you're going to be compounding. Now, this is because we assume compounded interest, where interest is also earning interest, and so this is the equation we can use. This is really an important equation in engineering economy. So now we can answer all of these questions. What return am I going to get if I invest in the stock at $89 a share and then sell it in 1 year at $102? Would I prefer to get $500 in 1 year or $600 in 10 years if I can invest at 5%? And I want to have $100,000 when I retire in 45 years, how much should I deposit now at 15%? So we can answer all these questions. We'll go ahead and go through them. So what return am I going to get if I invest in stock at $89 a share and then sell 1 year later at 102? So again, I'm going to use this equation. So F in this case is going to be $102 into the future. P is the amount I invest right now, or $89, and the N value is 1 year, and my interest rate is my unknown. So if I draw this equation, I can see I'm going to invest 89, get a return of 102 in 1 year, and the question is, what is the interest rate I earn? So I can just do algebra with the equation up there and solve for I, and in this case, it is a 14.6% return, which is pretty good. That's better than a bank. So if this year, that's what the kind of return we got 14.6. So now another sort of a common kind of question is if I would prefer to get $500 in 1 year or $600 in 10 years. And I often really recommend that you actually draw these cash flow diagrams because it'll help you visualize where I need to shift items. So $500 in 1 year or $600 in 10 years. Now remember, what I want to do is I want to compare apples and apples, not apples and oranges. So I will convert these to a common time frame. And I can actually use any point in time. I can use present value, I can use 1 year out, but I'm choosing to do it 10 years out. As long as they're the same, I can compare them. I can't compare them right now because they're in time period 1 and time period 10. So since I'm going to convert to the 10-year time period, the second alternative, which is $600 in 10 year, is already in year 10, so I don't need to adjust that at all. But the other one, I do need to adjust, so the $500, and I'm going to use this equation. I'm going to make it into a cash flow that occurs in year 10. So I'm going to find my p-value is 500. The number of years is 9. So I'm going to year 10, but this is already occurring in year 1. So the number of years I need to move it is 9. And I'm going to have 5% a year because that's defined in the problem, and I'm finding F. So I just do a calculation like using my equation, and I can see that $500 in year 10 is equal to $775.66, which is larger than $600. So I would prefer $500 in 1 year. So I hope that makes sense. So you're converting to common time period in order to make the decision, and then you say which alternative is better, and in this case, the $500 in 1 year is better. So this next problem is, what if I want to have $100,000 when I retire in 45 years? How much money should I deposit now if I get 15% return? Now I want to just recognize 15% return is a pretty high return. But we can definitely look at this. Again, I recommend drawing cash flow diagrams because it'll help you kind of organize your thoughts around this. I want to know what the p-value is given that an F of 100,000 and my interest rate is 15% and it's for 45 years. So I use this equation here and I plug in the answers in order to find P. I do a little bit of algebra here, and I get that if I put in $186 in and I earn 15% a year, I will have $100,000 in 45 years. So I hope that helps you to see that really the only equation you need in engineering economy is this equation. But you also need to understand that cash flows that occur at the same period of time are additive. And that's another kind of a concept that's important in engineering economy. So if you get $200 and then you get $500, that would be $700. But if you get $200 today and then $600 next year, you don't have $800. You have to include the difference in the timing in that. You actually, if I'm going to assume that I have a 5% interest rate, I'm going to say the present value or the value today is $200 plus $600, but I'm going to bring that back to today, find the present value of that $600 by dividing it by 1 plus the interest rate. So if the sum of $200 today and $600 next year is the same as $771 today. So I hope that makes sense. Let's look at another example. So this set of cash flows is sort of common. We'll have like an investment we made, and then we'll have return, in this case, over the next 5 years, $12, $6, $50, $50, $150. And what we want to know is what's the equivalent in time period 0, which is used as, which is called the net present value. What's the present value of all these cash flows? And what we do is we just go ahead and add them up. So $200, which is a negative number, doesn't need to be adjusted because it's already in time period 0. All the other ones need to be what's called discounted back to time period 0 by the number of time periods into the future at 5%. So when we do this calculation, it's $18.73. That is what's called the net present value of this investment. Now let's look at that a little bit differently. Like if we are comparing this to alternatives, we can say, well, we're going to have $200. Should we invest in this project, or should we go ahead and put our money in the bank at 5%? And so I'm going to do a calculation with that. So the first thing I need to know is, if I put my money in the bank at 5%, how much will I have into the future? And in this case, we're going to have $255.26, because we're going to put it in the bank and earn 5 years of interest at 5%, and that's the same as $255. So if we then take that and we calculate the present value of the $200 now and the $255.26 in 5 years, that ends up to actually be 0. So what's happened here is we say we can look at the alternative of making this first investment, or we can look at the alternative of putting the money in the bank. And in this case, 1873 is greater than 0, so it's better to make that investment on the top there and not just put our money in the bank. So let's look at the summary for this. We are looking at shifting cash flows with interest equivalent and then additive cash flows. And this is one of the most important equations in engineering economy. Again, in this video, we talked about topics under the area of investment analysis.